Okay, this is the module 3 investigation 4. So function composition and chaining together two function processes. All right, so this is we're gonna talk about the composition means one function actually contains two functions. Okay, in relation as a composition. So let's see what's the composition. So let's look it up as this pictures. So what do you do is actually you have a two factories, okay, two machines, okay. So if you put it in the one of the input into the g function, and then you get the output from the g function, but that output becomes input again for the h functions to come out as output. So actually the input and then output, okay. So but it goes into the two different machines to get it out, okay. All right, so function compositions. Function composition is a process of the chaining together two or more function processes by linking the output quantity of one function with the input quantity of another function. So the function created by doing this called the composite functions. Okay, so let's look it up. The number 4. Number 4 give us a very good idea for the what the composite function is. Okay. So number 4, the following graph shows two functions, f and g. So this is a f and this is a g. Function g takes as its input as a high temperature and in degree Fahrenheit, and output is going to be the expected tendency at the neighborhood carnival. And function f takes as input number as a number of the people attending the carnival, and the output is going to be total expected revenue, the money that they make. Okay, so what we do is there's something that has to be in common. Okay, so which is input from the g function was temperature, right? And the output was the expected attendance, and then the output now becomes the input of the f functions, and then from that input you got the output. So that means actually whatever temperature, and then you get the expected revenue. Okay, so you put it into the two the machines to take it out. Okay, here. All right, so A, if the forecast predicted a clear sky and a high temperature of the 45-degree, and what is expected revenue from the carnival today? So, and then what if the forecast predict the high temperature of the 75? Okay, so we'll think about two temperature here. But we are looking for the expected revenue from the temperatures, okay? All right, so let's look it up. So first one is a 45-degree, right? So 45 degrees right here, right? So if you go to graph G, and then expected to the revenue, so which means 45 is about 200, right? Let's make the approximation. So G of 45 give us the 200 people attending the carnival, okay? And then use that 200, right? Use a 200 to right here find it as an input for the f function. Then we can think about the how much it makes, okay? So it's a little bit lower than the 600. So I want to say about 500, okay? So, and then f function using 200 people give us a $500, right? Okay. Now we are using the 75-degree. So 75-degree right here. 75, okay. And then if you use the f function, so how many people are attending? Can I say about 650? So g of 75 degree give us 650 people comes in. And then 650 people is about here, right? About here, right? And then if you go right here, and then how much? Let's say about 1600. Okay, so or 1650, right? Then f of 600 people makes it as 1650. Okay, so even though you're using the temperature, the answers comes out as the revenue. B, the function H input of the high temperature in degree Fahrenheit, output is expected revenue. So you create another function graph, and on the given axis plot the list of 5 coordinates points representing the input output pair of for age. Okay, so let me make the table to use. Okay, so make a table. But good thing is we already have a temperatures and then the revenue, right? So 45 temperature give us a 500, and then 75 temperature give us a 1650, about that, right? And then what else I want to use? Let me use a 0. What about there's a 0 degree? So 0 degree, if we go back to here, so 0 degree is about 50. So 50 is about here, give us about 150 is about 150. Okay, so 0 degree, it's about 150. Okay, so two more. Now let's use a degree of 20. So 20 degree. So the 15, 20 is about here, right? And then it's about 100. And the 100 degrees is about 300. Yeah, we just need to approximate, isn't it? And then one more. Let's use the 70. So 70 degree is here, right? That's 70, right? And about here, which is, can I just say 500, close to 500, right? Then 500 in here, right? Give us a little more than 1200, 1300. Okay. Then now what I do is I'm gonna plot them in. So let me label first, okay? So each interval I wanna say 10, 20, 30, 40, 50, 60, 70, 80, 90, right? So 10, 20, 30, 40, 50, 60, 70, 80, 90. And then on the y-axis, I want to use make that as every 4 is 500, 1, 2, 3, 4, 1,000, 1, 2, 3, 4, 1,500, 1, 2, 3, 4, 2,000, 1, 2, 3, 4, 2,500. So 500, 1,000, 1,500, 2,000, and 2,500. I think that'll be enough, right? Because the largest number is 1650 anyway, okay? So when it's a 0 temperature, so this is temperature and this is a revenue, right? So 45 degree, which is, this is a 40, right? So 45 is here. So 45 is about 500. So one of the point is right here. And then 75 degree, which is this lady, 75 is here. 1650, so 16, this is 16, so this is about here. And then the 0 degree is about 150, right? So 0 is right here, right? So 150, so which means this is about here. And then 20 degree, which is right here, is a 300, so right, so 250 about here. And then 70 degree is about 1300, okay? So 1300, a little bit more here. Okay, so this is a graph we have. Okay, all right, so we finished the graph, right? So we are using the temperature to find out how many people attending the carnival, and they're using the number of the attendants to find out the expected revenue too. Okay, so now let's talk about the composition notation. So notation is we're using these symbols, okay? So this is open that's about here. Okay. So number 5, we are using the exercise 4, which we just finished. Explain the what f of g of 70 represents, okay? So the 70 we have here, okay, this is input in g functions. Input in g functions, okay? So which means the g function was input was temperature, right? Isn't it temperature, the g functions? So input of the, so temperature of the 70, and then you get the output of the whatever 70 give, and then the output of the number of the people, and they give us the revenue of the expect from the number of the people, right? So this whole thing is talking about the expected revenue. Of course, it's in dollars from the neighborhood caliber. When the temperature is 70 degree Fahrenheit. B. In the context from the exercise 4, explain the why g of f of 70 does not represent a real world quantity, okay? So, because this time is a 70, in here, 70 is from the f function. So, input for the f function, 70 is the number of the people. So, now number of the people. Okay, so number of the people, and then you get the revenue, and then, which means the g of whatever, right? This is going to be the revenue. But g function is the input should be the temperature. So temperature does not equal to the revenue, right? So that's why it doesn't make sense. So the output of the f function and input of the g, right? So this is how you write it. So the output of function f and the input of the g are not the same. So that's why we are not able to compose these two functions in this way. So now C. Let's define a new function k that is a composition of the f and g. So k of x is f of g of x. Explain what the equation 800 equal to k of x represent, and explain how you can find value of x satisfy the situation. So first of all, k of x represented as is a whole thing, right? So 100 this is actually the whole thing was about revenue, right? So which means 1800 is should be the money. And then now we have to think about the input for the f function. So which means we have to find the how many people. So 1800. So let's look at the graph here. So 1800 give us this number of the people, right? Which is about 700, right? So this is gonna be give us a 700 people. And then from the 700 people, right? And then use from the 700 year, and then give us the x as a temperature here, right? Okay, so about 77 or 78 degree. Okay, so we can we can do as a backward, okay? Instead of finding the temperature to get the attendance, to get the revenue, right? We get the revenue to find out the number of the people, and then we can get to the temperature too. So back and forth, we can do either ways. Okay, all right, so I mean, number 6, I don't need to do this, but this is a good exercise for us to do, okay? So I might not gonna do in class, but I wanna do right here. Okay, so number 6, use a table to evaluate and solve each of the following. So whatever always, okay, so here we go. So whatever g of f of x in it, this is always the input. And then f of x by itself, this is actually, the whole thing is the output. Okay, But if you put it into the g function, and then this becomes input again. So this is so let's be started here, okay? So this is input of f, and then this is going to be output of the whole thing, and then becomes input again, input of the g, and then once you figure it out, it will be the outputs, okay? And then g of f of x is the whole thing is about the output, okay? All right, so which means this is an input, okay? So -1 is an input for the f function. So input. So what is the input? Your input. All the input is right here. Input is right here, and then this is the output for the f function, and this is the output for the g functions. So input is -1. So you go to -1, and then use the f functions, which is -1 give you the 3. So and then 3, right? And then this means it's going to be g of 3. And then that 3 becomes input for the g function. So 3 is here. And then you look for the g function to find the output, which is a 0. So this is a 0. Let's do b. Now input of the 3, and they use the g functions to get 0, right? So which means you got f of 0. Now the 0 becomes input again from here. Use the f function to find the output, which is a 4. Okay, now what about next one? Input is a 3 right here. And use the f function, which is -2. So this becomes a f of -2. And then you use a -2 as an input. Use the f functions again, so which is output of 0. D, the g of 0, right? So this is input of the 0, which is right here. And then g function, output is a 2. So this becomes g of 2. Then 2 becomes input for g function again. So output is a -1. All right, now the E is f of g of 3, right? So this time is actually we're looking for the x, which is input eventually, okay? So this is actually the output for the f functions, okay? Output for the f function. So output for the f function is actually the 3 is right here. And then you're looking for the input. So input is a -1. So which means this is f of -1 is 3. Okay, and then now the -1 is equal to the g of x, isn't it? So now the g of x equal to -1. So -1 becomes output for the g function. So output for the g function is right here. And then what's the input? Input is a 2. So x should be the 2. And then you can do the same thing as the number 7 too. So same idea, okay? So that's 2.5 is input for the g function. So g function graph is right here, isn't it? So 2.5, which is going to be here to give you the 1.5, isn't it? So this become f of 1.5. And then 1.5 is input again, which is right here. And then use the f functions. F functions right here. So I want to say 3.2. So this answer is a 3.2. Okay, g of f of 4. The same thing. So 4 is the input for the f function. So find the 4. F function is right here. So I want to say 4. Okay. So this is g of 4. So use 4 as an input again. 4, and then use a g function. So little less than, so 0.8. And then 3.5, C, 3.5 is here, right? So use a g function, which is 1, isn't it? So it's a g of 1, and then 1 is right here, but you have to use the g functions again. G functions right here, right? Isn't it? So maybe 2.6. So this becomes 2.6. Now D, determine the value of x this time. So 2.5 is the output for the f function. So 2.5 here, f function is this one. So this is about 1.1, right? So this is f of 1.1 give you the 2.5, isn't it? And then g of x is now 1.1. So 1.1 is about here to use the g function. So g function is about here, right? Okay, so I want to say 3.4. So x is about 3.4. Okay, alrighty. So that's all for this investigation. Thank you for listening.